The nature of energy remains elusive as it cannot be directly measured. Nevertheless, it is a fundamental aspect of our understanding of the physical world, which is driven by energy. This raises the question, how the idea of energy was developed and conceptualized. Gottfried Leibniz discovered in the 17th century that the product of the body's mass and the square of its velocity remains constant in elastic collisions. This quantity was referred to as vis viva by Leibniz, which means living force. Leibniz made a discovery that contributed to the idea of a basic entity that cannot be created or destroyed. Thomas Young coined the term energy for this entity in the 19th century. As time went on, it became evident that there are many different forms of energy: thermal, electrical, chemical, nuclear, and many more. The idea of energy being indestructible developed into the principle of energy conservation, which is now recognized as the first law of thermodynamics. Energy cannot be created or destroyed. It can only be converted from one form to another. One definition of energy proposes that energy is the capacity for doing work. The symbol for energy is capital E, and the unit of measurement is the joule. It's important to understand that while energy can change from one form to another, a certain amount of energy is inevitably lost during this transformation. This lost energy is the portion that cannot be utilized. This principle is recognized as the second law of thermodynamics. It is essential to accurately quantify the useful portion of energy in each energy transformation process. This portion of energy provides valuable information regarding the efficiency of each energy conversion device. Since every machine is essentially an energy conversion device, its efficiency is determined as a ratio of useful energy to the energy consumed, denoted by the Greek letter eta. By multiplying the result by 100, energy efficiency can be expressed as a percentage of energy consumed that is converted into a usable form. This is why all machines are labeled with energy efficiency ratings that are easy to understand, using letter grades such as A++, B, C. Where does the energy difference between input and output go? Friction between moving parts generates heat, vibrations, noise, each of which leads to energy loss. This part of energy is always converted into a form that cannot be recovered. A light bulb is designed to transform electrical energy into light energy. However, apart from generating light, a light bulb also emits heat. This process is irreversible. Regular light bulbs typically have an energy efficiency of around 10%. Almost all the electricity consumed is converted into heat. LEDs are much more efficient, converting approximately 50% of power into light energy. Nevertheless, half of the energy consumed is irreversibly lost. The discovery that there are losses in every energy transition has cast new light on the age-old concept of a machine that can operate indefinitely without losing energy, the perpetual motion machine, a machine that drives itself indefinitely. Countless concepts have been proposed throughout history about the development of such a machine. However, because losses are unavoidable throughout each energy transition, Each machine must somehow compensate for this energy lost in order to continue working. Everything we do requires energy. Every person on Earth has genuine energy needs that must be met, and the population is growing. The planet's energy reserves are finite. To continue advancing in technology and improving the quality of life, society must secure clean and renewable sources of energy. Without energy, civilization cannot thrive.